The next one, this question is quite long, so pay attention and pause the video and go through the question and again. Okay, see, the question is, a small town with a demand of 800 kilowatt of electric power at 220 volts is situated 15 kilometer away from an electric plant generating power at 440 volts. The resistance of the two-wire line carrying power is 0.5 ohm per kilometer. The town gets power from the line through a 4220 volt step down transformer at the substation in the town. In this, 3 sub questions. First one, estimate the line power loss in the form of heat. Second, how much power must the plant supply assuming there is negligible power loss due to leakage? Third, characterize the step down transformer at the plant. Okay, so carefully understand the question, then we'll solve the answer. You guys will see the solution. See, we have the total electric power required. Required is 800 kilowatt, correct? That's 800 into 10 to the power of 3 watts. Now, the supply voltage is what? 220 volts, because that's what they told. 800 kilowatt, 220 volt, right? Now, see, the voltage at which the electric plant is generating, that is 440 volts, right? So, the required power and the voltage you know, and the generating voltage you know, right? Now, the distance is what? 15 kilometer. See, they have given you that the resistance of the two wire lines carrying the power. So, there are two lines carrying the power. So, they have 0.5 ohm per kilometer. That means the total resistance will be 15 plus 15 into 0.5, because 15 this side, 15 this side, correct? So, the net resistance will become 15 ohms, correct? Right. Now, we have the input voltage to be 4000 volts and the output voltage to be 220 volts, right? Because that was given in the question. So, what we get is the RMS current in the wire. So, RMS current will be I is equal to P divided by V1. Okay. So, that is 800 into 10 to the power of 3 by 4000. Okay. So, why we are doing this is we need to know the input current and the output current, both we need to know, okay, because the transmission is happening, correct? So, we have 800 kilo divided by 4000, which gives you 200 ampere. So, this is the current, okay. Now, we will talk about the line power loss, the first question. See, line power loss, it's basically dissipated as heat, that's I squared into R. So, I value is 200. So, 200 square into 15. So, that's 600 into 10 to the power of 3. So, 600 kilojoules of energy is being lost here, okay, as heat. Understood? So, this is the answer for the first question. Now, the second question, they are asking you the total power, right? See, here the total power supplied by the plant will be whatever which is required, which is 800 kilowatt. And just now we saw 600 kilojoules of energy is being wasted as heat, right? Meaning that much of power has to be generated by the plant, correct? So that means the total power supplied will be 800 kilowatt plus 600 kilowatt, which is 1400 kilowatts. So what we are doing, we are neglecting all the other things, the loss of energy, right? So 1400 kilowatt of power has been supplied by the plant, okay? Now we'll go to the third one, third sub question. See, third sub question, the voltage drop in the power line. Okay, the voltage drop, because we are characterizing the step down transformer, right? So here the voltage drop in the power line is I into R, which is 200 into 50, which gives us 3000 volts. Now see, the total voltage transmitted from the plant will be 3000 plus 4000. Because the rating is 4000 to 220, right? So, we have 3000 plus 4000, which is 7000 volts. Now, as per the power generated, it is 440 volts, correct? So, what we have is the rating of whatever the transformer we have, it is from 440 to 7000 volts. So we are characterizing the transformer, that is nothing but the rating of the transformer is 440 to 7000 volts. Okay, so this is the answer for the third one. Alright.